Before we get into setting up a linear model as an inequality, let's kind of review of how we set up linear models. Linear models is just another term for writing a linear equation. It says in 1988 the number of U.S. citizens who had backpacked or wilderness camped was about 9.1 million. From 1988 to 1998, this number increased at a yearly rate of about 850,000. Write a linear model for the number in millions of U.S. citizens who had backpacked or wilderness camped during this period. Okay, couple things I want to remind you of. Remember our slope-intercept form. This m here, that's our slope, but remember it's also our rate, how much something is changing. The b here, that's our y-intercept, yes, but it's also our initial value when we're talking about setting up a linear model. So when we're looking at this right here, where do we start out at? Well, we're going from 1988 to 1998, so we started out at 9.1 million. That's your initial value. That's going to be your y-intercept. If you were going to graph from 88 to 98, at 88 on the y-axis, your initial value would be 9.1 million. Now it does tell us to write it in millions, so we can just write it as 9.1. Then it increased at a yearly rate, look at the word rate right here, of about 850,000. That means every year it increased 850,000. Here's the problem. We can't just write 850,000 here. The reason, because it wants it in millions. We could write this out, and you could write it as 850,000 if we were to write this as 9,100,000. Wouldn't be really writing it in millions, but that would be a correct equation. How we want to do this is if we had 850,000 and we want to write it like in millions, basically, remember the millionths number would be out here. So if we move our decimal point over, we would get 0.85 in millions times x plus 9.1. Again, the reason for that is if I just put 9.1, it's 9.1 million. If I were to go 9.1 times a million, that would be my answer. That's why if I were to go 0.85 times a million, I would get 850,000. Don't focus on that so much. I want you to focus on remembering that when we set up a linear model, one of the things we can do is if we're given an initial value and a rate, we can put it into slope-intercept form. So let's use that thought for this next example. You plan to publish an online newspaper that reports the results of mountain bike competitions. You do not want your monthly costs to exceed $2,370. Your fixed monthly costs are $1,200. You must also pay $130 per month to each article writer. How many writers can you afford to hire in a month? All right, look at a couple things here. We have fixed monthly costs that are $1,200. That means every month we're going to pay that. Now it's a little bit different than here. Okay, it's not necessarily our initial value, but it's a fixed cost. We're adding B. We're adding this every month. Just like here, we're always going to have 9.1 million plus however many we add each month. We must also pay $130 per month to each writer. So when you see these things like, okay, I'm going to be paying $1,200 and I've got to pay $130 per month, hopefully you're starting to kind of get the gist of when you see this per month here, that means you're going 130 times however many months or many writers, are there. Okay? So we have 1,200 plus 130x. Okay? So we're paying 130 each month to each writer. Now we do not want it to exceed, so instead of putting a y here, we don't want it to exceed 2,370. What does that mean? Does that mean I want it to be less than 2,370? Do I want it to be greater than 2,370? Or less than or equal to? or greater than or equal to. Well, think about it. If we don't want it to exceed this right here, we want it to be smaller than that. Okay, let me say that again. We don't want our monthly cost to exceed $2,370, but it can be equal to it. So we're going to say it has to be less than or equal to our fixed cost plus what we're going to pay per writer. And I guess we're just really right now talking about each month. So our fixed cost plus, because this is how many writers can we afford a month. So our fixed cost plus how many writers we can afford to pay, and we want that to stay less than, not to exceed, 2,370. Once you set up your inequality, hopefully it's pretty easy to solve. We're going to subtract 1,200 from each side. Always double check to make sure these do cancel. You bring down, since this is a plus sign, a positive 130x. Didn't do anything multiplying or dividing, so I'll just bring down my less than or equal to. And if you do this, we get 1,170. Divide both sides by 130. 130 divided by 130 is 1x. 1,070 divided by 130 is 9. Before I bring down my inequality, did I multiply or divide by a negative number? No, I'm divided by a positive number. So I can bring my inequality straight down. So that's great. X is less or equal to 9. What does that mean? Make sure you answer the question up here. How many writers can you afford to hire in a month? 9 or fewer, 9 or less. Because that inequality means the numbers can be less than 9 or equal to it. So I can hire up to 9, but it's okay if I hire fewer, because I want it not to exceed 2,370.